Okay, so today we're going to start talking about finding cube roots. All right, so before we jump into the cube roots, let's just take 1 second and talk about square roots. All right, so you guys know how to take a square root. All right, I hope. And we talked about this a little bit the other day. So let's say I've got the square root of 9. Do you guys remember factor trees? So if I take 9 and I do a factor tree, what multiplies to make 9? We've got like 3 times 3, right? And those are both prime numbers, so I circle the prime numbers. And if I wrote this out, this would be 3 times 3. So I have 2 of these, okay? So instead of putting 9 under here, I'm going to say that this is 3 to the second power, because I have 2 of them. All right, so if I would have had 4 of them, then I would have put 3 to the 4th power. All right, so out here in this little like hook, there is a number there, okay? And that number is a 2. We don't write that 2 because it's just understood to be there. Kind of like if I say x, then the power to that is a 1, but we don't write that, correct? Or if I say x, we don't say 1x, all right? I don't like that, so we don't put the 1 in front of it, all right? And what happens when you take the square root of a number is you would take this base and you can rewrite this with an exponent. So you take this exponent and you divide it by this root number, and 2 divided by 2 gives you 1, and 3 to the first is just 3. So that's the long way of getting around the number that multiplies by itself to get 9 is 3. Okay? So let's say I did the square root of 16. If I did the square root of 16, I've got, oops, wrote it a little high, 2 times 8. 2 is a prime number. 8 is 2 times 4. 2 is a prime number. And 4 is 2 times 2. And those are prime numbers, right? So I have 1, 2, 3, 4 2's. And I can rewrite that as 2 to the 1, 2, 3, 4 of them. So I can replace the 16 with 2 to the 4th. And since I have this little 2 out here, I can say, okay, well, I can rewrite this as 2 to the 4 divided by 2. What is 4 divided by 2? It is 2. And 2 to the second power is 4. What number times itself makes 16? 4. Okay? So the factor trees come in really handy when you maybe don't know what the number is. Okay? So we can take that and we can apply that to cubed roots as well. All right, so when we're finding a perfect cube root, you're trying to find the number that times itself 3 times will make that number, okay? So if I were to do a factor tree, which we're going to do on all of these, I've got 8. 8 can be split into 2 times 4, and 2 is a prime number. And then 4 can be split into 2 times 2, and that's both a prime number. So if I wrote this out as like a prime factorization, you would have 2 times 2 times 2. And how could I write that with a power? That would be 2 to the 3rd power. So I'm going to take this 8 out. And you want to make sure when you write these 3's that you put them in the little hook area. Because if you don't, some people will write them like this. And then I can't really tell if, you know what I'm saying, if you meant for that to be 3 times that or whatever. Okay, so now I can rewrite this as 2 to the, take your power and divide it by the root. 3 divided by 3, which is 1. So we get 2 to the first, which is just 2. So 2 times 2 times 2 is 8, right? So you just found the cubed root of 8. Okay? Now, when you take an even root, you can't even root a negative number, because if I try to take like the square root of, let's say, -9, if I take a number times itself, it always comes out to be positive. If I do 3 times 3, that's +9, right? -3 times -3 is +9. You can't even root a negative number. It doesn't work. Okay, but you can odd root a negative number, and your answer comes out to be negative. So when you see a negative underneath that odd root, then in the end, your answer is going to be negative. Okay, so I'm just going to drop that down and remember that my answer is negative, and I'm going to focus on the 27. So we're looking for a number times itself 3 times that makes 27. So let's do a tree. So 27, I could do 9 times 3. 3 is a prime number. And then 9 is 3 times 3, both prime numbers. So if I wrote this out, it would be 3 times 3 times 3, which is 3 to the third power. So I can take out the negative 27, all right, because I'm already realizing my answer is going to be negative, correct? All right, so I've got the cubed root of 3 to the third. Now if I wrote that with a power, that would be 3 to the, take that exponent, and then divide it by the root. So this would be 3 to the first, which is just 3. So the answer is -3. And if you take -3 times -3, that's 9, right? Times -3 is -27. Okay, so you should be able to multiply this number 3 times to get this number underneath. Okay. All right, so when we move to fractions, it's kind of like doing 2 problems in one. So up here on top, I'm going to cube root the top number. And then I'm going to put my division bar, and then I'm going to cube root the bottom number. So you kind of split it off into 2 separate things. So 1 is a perfect everything. It's a perfect square root. It's a perfect cube root. It's a perfect everything. If I cube root 1, what times itself 3 times makes 1? 1. All right, so on top, I already know I'm going to end up with 1. I don't even need to mess with that. And some of these you will have done on other problems, okay? And so we'll talk about that on the homework. So we've got to find a number that multiplies by itself 3 times to make 64. Now, if you were guessing, you could probably figure out what that is. But we're going to do a tree because I want you to practice the tree anyways. All right, so what multiplies to make 64? Well, we could do 2 and 32, right? And sometimes there's more than one way to do it. So 2 is prime. 32, we could do 2 and 16. 2 is prime. 16, we could do 2 and 8. 2 is prime. 8, we could do 2 and 4. 2 is prime, and then 4 is 2 and 2, and those are both prime. So how many 2's do we have? 1, 2, 3, 4, 5, 6 2's. So we could write that as 2 to the 6th power, right? So I've got my cube root out here, and then instead of writing 64, we're going to write it with its prime factorization, which is 2 to the 6th. So I still have the 1 on top. I just kind of leave him alone. So on the bottom, I've got my number 2, and I'm going to raise that. So take your power and divide it by the root. I'm going to write that as a step. That way we don't forget later. So I get 1 over 2 to the 6 divided by 3. What is 6 divided by 3? 2. So 2 to the second power. And what is 2 to the second power? 4. So if I multiplied 1/4 times 1/4 times 1/4, I would get 1 over 64. Okay? All right, so let's do the same thing on D. I've got the cubed root of 27. I got to do the top, and then I've also got to do the bottom. So we'll have 2 factor trees this time. Now 27. Did we do that one already? All right, so we did the 27 already, correct? That's 3 to the third. So on your homework, you can do this too. If you did 27 on problem number 2, I won't make you do 27 on problem number 4, okay? So instead, I'm just going to write refer to part B. That way you can say, okay, well, we didn't do the factor tree. Oh, but it's on part B, okay? So the cubed root of 27 is 3, correct? We already figured that out up here. It's just not negative because this one's not negative, right? Okay, so then we'll do a factor tree for 125. Okay, so we can divide 125 by 5, and we get 25, right? And 5 is prime. 25 is 5 times 5. Those are prime. So if I wrote this with a power, this would be 5 to the third. Now, what always happens when this number matches this number? So if you look up here, this number matched this number matched this number. What always happens when the power and the root are the same number? They end up just making a 1 right here, correct? So essentially they're just canceling out, right? So instead of maybe going that step, I can just say this is going to be 3 over 5. As long as we understand that the reason that happens is because they divide to make 1, okay? Okay, so now we're going to up it just a little bit because we have an expression. So this is a cube root. It kind of looks like 2 to the third because of the way they write this. That's why I hate these, but that's okay. So the first thing you want to do is you want to focus on this root right here, okay? It's kind of like, you know, a grouping symbol. You want to get rid of the root and just come up with whatever the cube root of that is. So the 2 and the minus 3, you're going to use those when you get done. Is everybody with me? So let's focus on this negative 216. Now you already know that the cubed root of a negative is going to come out to be negative. So let's just focus on the 216. All right, so 216 is even, so I know it divides by 2. So let's go with 2 and 108. 2 is prime. And then 108, that's even, so we know that divides by 2. So 2 and 54. 54 is even, so that divides by 2. So we've got 2 and 27. All right, and 27 will divide by 3, so 3 and 9. And 9 divides by 3, so 3 and 3. So this time we don't have one number, we have 2 of them. So you have 2 of the 3s, so 3 of the 2s, so 2 to the third, and then you have 3 3s, so 3 to the third. Now, both of these powers divide by 3, right? Okay, so that makes it easy. So right here, I'm going to keep the 2, and under my root, also that little negative, so that we don't forget about it, let's just stick it out front because this is being multiplied, so we can do that. All right, so I've got a cubed root of 2 to the 3rd times 3 to the 3rd minus 3. So we're still just focusing on this part. Is everybody with me? Save this stuff until you get done with this. So you have the negative 2 out here. What's going to happen to this 3? It's going to end up canceling, correct? Now you might want to view it like this and say, okay, this is the cubed root of the 2 to the 3rd times the cubed root of 3 to the 3rd. You can split this root into 2 separate ones so that you don't accidentally think that maybe it canceled and then this one had to stay. All right? So since I'm about to get rid of my root, I'm going to put a parenthesis here so we don't forget that we're going to have to multiply this part right here. So in here, what happens to these 3's? They cancel and you have 2 times. What happens to these 3's right here? They cancel. So I have a 3. Close your parenthesis, and then you have minus 3. So now, what do you have in here? 6. So you have negative 2 times 6 minus 3. Now it's just kind of like what we did yesterday. Negative 2 times 6 is negative 12. And then minus 3 gives you negative 15. All right, so on this one, that one's a little bit different. So it makes these squatty parentheses. They're really like kind of like those. All right, so here's something about roots. If I put a cube on the outside, that means I could also put it on the inside. So this is the same thing as saying 125 to the 3rd power. You can take this and put it inside as well. So what's going to happen to these right here? They cancel and you just have 125. Let's say you didn't realize that, so maybe you did the cubed root of 125. We did that one on the first problem, right? What was the cubed root of 125? It was 5. And then you would raise it to the 3rd power. Well, 5 to the 3rd power is 125. So either way you work it, it comes out correct. All right, so now we're going to have an expression where we have to substitute a number in, and then we'll do the process that we just learned how to do. So everywhere that we see an x, we're going to plug in 192. So up top here for this x, 192. And then underneath on top here, 192. Now, will 192 divide by 4? All right, it's 48 plus. Now here's the thing. Normally when you see a cubed root of a number on top and on bottom, then you start cube rooting, correct? And so far we haven't had anything that would divide. However, 3 is a prime number, and it is not a perfect cube root. Okay? So will 192 divide by 3? What is it? 64? All right, so that made that a lot better, correct? It dropped our number, and we didn't have to do the top and the bottom. So we're going to go ahead and what was the cubed root of 64? We found that earlier. It is 4, correct? All right, and 48 plus 4 gives you 52. So do you see what I'm saying, though? Sometimes you'll do one in another problem, right? And then you already know, like, what it is. Okay? All right, so on part B, we're going to put in 1 over 27 for both x's. So I have 9 here right up next to this x, so I need to put parentheses to show I'm multiplying. Plus the cubed root of 1 over 27. So what is 9 times 1 over 27? All right, so we get 1/3. Now, 1 doesn't divide by 27, so we're going to have to cube root the 1 on the top, and then we're going to have to cube root the 27 on the bottom. So I've got 1/3 plus, what is the cubed root of 1? 1. And what is the cubed root of 27? 3. And if we add 1/3 and 1/3, we get 2/3. Right? Remember, when you add fractions, you don't add the bottoms. They just have to be the same. So 1/3 and 1/3 makes 2/3. Okay. Okay. So we're going to plug in -6. So I've got 5 times the cubed root of 3 times -6 minus 9. Always make sure your root covers everything that's underneath it. All right, minus 7 times -6. So before we can take the cubed root of this right here, we're going to have to figure out what that number is, correct? So underneath here, what is 3 times -6 minus 9? -27. And -7 times -6 gives me thank you. All right, so let's focus on our square root right here, our cube root. We found what the cubed root of -27 was earlier, correct? What is it? -3, correct? Because of this negative right here. So we can replace that. 5 times -3 is -15. And -15 plus 42, 27. Okay, we're going to find the surface area of this baseball display case. So I know that the volume is 125 inches cubed. So I have a question. How do you find volume? Length times width times height. So if I have S times S times S, how can I rewrite that? S to the third, right? And that's my volume. So, I mean, if this was a 4 times 4 times 4, so equals 125, right? So if we want to find the surface area, we're going to have to figure out the S's, right? So here's my thing. You're trying to find a number that will multiply by itself 3 times to get 125, right? What number would that be? Okay, so the side is 5. Now, how do you find the surface area of a cube? How do you find the surface area of one side? Like this side. We already know that it's a cube, so length times width, correct? Okay, so if I did length times width, that would be 5 times 5, which is 25. So the surface area of one side is 25. How do you figure out what all of them are together? Multiply by what? How many sides are there? 6 sides, right? You have 1, 2, 3, 4, 5, 6. So the 4 sides and then the top and the bottom. So multiply by 6. And what do you get? 150 inches squared.